In this video I will start a realistic boat system. This covers making the master actor for it, so it will be used in the next few videos. Boats have buoyancy, so they float realistically in the water. When you are near it, a UI prompting you to enter will fade in, and pressing the key will make the player enter the boat. The player will sit in the boat, or enter it differently based on a very easy to choose enumeration value. Pressing the interaction key again will make the player exit the boat. Finally, the boat also will spawn foam using fluid simulation. The hull is also masked so the water won't show up in the boat interior. The video shows making all the functionality for the different boat types to work, which will be the next following videos after this, so you must follow this if you want to add any of those other boats. This video will require the water plugin which I showed how to set up in the realistic island video. If you only want to make the boats, you can watch just the ocean parts of that video, or alternatively watch a different video on how to add water with the plugin, then come back to this video. Please comment down below if you are stuck with how to set up the water prerequisites, and I will help you out. The boat system also uses interfaces made in the swimming system, but you can make them newly for this one if you need. However, it is better to have swimming too, so you can actually swim to different boats to enter them and exit realistically. First we will get animations. I will use Mixamo for it. First will be sitting idle. Make sure to download it without skin. Then get this male locomotion pose. You can get any pose where the fists are closed, as this will be layered only to the hands to make them closed when needed. I will use the Mixamo converter to convert them to the Unreal rig. I will put a link to the software in the description. Now go to Unreal Engine. I will make a new folder for boats. Import the animations. I will rename them to be more appropriate. Now make a new folder for enumerations and structures that will be used. The first one will be called Boat Enter Type. This will contain the different types of ways the player will stay in the boat. For the main tutorial series, I will add sitting drive, standing, sitting jet ski, and player hidden. The next enum will be called rotation axis with the values roll, pitch, and yaw. Now make a structure called propellor. It should have a static mesh input and a float input called mesh and speed respectively. Set the default speed to 1. This structure will be used to set up the propellers the boat has. Duplicate the struct and rename it propeller objects. Change the mesh variable type to static mesh component. This will be used to access the propellers as actual spawned components. Now make a new blueprint interface called Interaction BPI. This will be used to make a very simple interaction system to enter and exit the boat. The first function should be called Set Interactable with an input called Target Actor of type Actor. Add another function called OnInteracted with an actor input called Interacted Object. Add one called Interacted Secondary. Add another one called Fade Interaction Text with a Boolean input called Fade Out. Open the Water Interaction BPI which I made in the swimming tutorial. You can just make this as a new BPI if you did not follow that tutorial. I will categorize the functions quickly. Add a new function called Enter Boat. Now make a new blueprint class of type pawn for the master boat blueprint. We need to use pawn so that it can actually be possessed. In the enter boat function, add an input to reference the boat pawn actor. Then add a boat enter type input. Add another function called exit boat with a vector input for the exit position. The next one will be called play boat montage with an anim montage input. Then add one called set boat IK. It should have Boolean inputs for each hand IK enabled and corresponding vector inputs for the positions of them. Duplicate it and call it set boat IK initial and remove just the enabled inputs. The final function will be called get boat variables. Add the following outputs for it. We will use this macro throughout, which I added to a global macro library so it can be accessed in any actor. You can copy it if you need. Now make a global function library. It will have a function called smooth relative rotation with a scene component input, a rotator input and a float input called target rotation, and interp speed. Set the default value of interp speed to 5. Set the relative rotation of the target to AR interp 2. Copy the setup shown. This will be used to smoothly change the relative rotation of any object using a simple function. Now make a folder for UI. I will make a very simple UI which has text in the bottom for an interaction prompt. I will speed this part up so you can skip to the time shown if needed. In the graph, set the render opacity of the text holder to 0 so it is hidden by default. I will now get an example boat mesh from Quixel. By the time of this video's release, Quixel Bridge is disabled and you have to use Fab, which in my opinion is a huge downgrade as you can't just directly import into Unreal Engine with the materials. You can use any mesh you want for this, however, so you can import your own. The boat systems will use static meshes for the main body as opposed to skeletal meshes, so keep that in mind. Open the boat mesh and add 26 DOP simplified collision, which is the most complex base one. We need collision since the boat will be a physics object. Then add a socket called player socket. I have already tested the position for this, but it is where the player will be moved to, so make sure you find the proper value for it by testing once the enter boat mechanic is done. Now open the boat pawn actor as we can start with it. Add a static mesh component and drag it onto the parent to make it the root. I will set the default mesh to the one I downloaded. Set simulate physics to true. I will explain how the mass is used later. The collision preset would have changed to physics actor after you simulate it. Now add a spring arm. I will increase the target arm length to 1200 so it is further back. Make sure you enable use pawn control rotation. Uncheck inherit roll. This keeps the camera upright even though the mesh will rotate in roll. Add a camera to the spring arm. You can see the boat is facing the side relative to the camera when it should be facing forward and away. This depends on the mesh, but the Quixel one needs to be rotated, so I will bake a 90 degrees rotation to it using Unreal Engine's modeling tools. If you are using your own mesh, just make sure it is rotated correctly so you can do it externally too in a program like Blender. It is facing the correct way now. Adjust the spring arm's Z position so it is at the center of the boat so it pivots correctly. Add a scene component called foam scene. Move this a bit back to where you want the foam to spawn from. Now add a box collision called enter range. Change the box extent so it goes around the boat. This is the box the player must be in to enter the boat. My boat is a bit small, so we'll increase its default scale by baking a transform onto it. It looks better now. Add another scene component called exit position and position it where you want the player to spawn when exited. Finally, add a buoyancy component. We need to set up pontoons to describe the floating points. Add 2 elements to it. To find the locations, add a scene component. For boats structured like this, 6 pontoons should be enough. First we need them at the back corners of the boat. Copy the location and paste it for the first pontoon. Change the Z value however to something like 50, although this value will require testing. Copy the position for the second pontoon and change the Y value to the opposite side by inverting the sign. This only works if the boat is symmetrical, which in almost all cases should be. Repeat the process for the other 4 pontoons, 2 which will be in the middle and 2 at the front. I will add the boat in the level over the water to test it. To visualize the buoyancy, you can use the following console command after pressing the back quote key. The buoyancy is working well. You can adjust the pontoon locations to match your boats. The buoyancy coefficient is used to control how strong the buoyancy force is. Buoyancy damp will realistically stop the boat gradually. I will increase it to something like 5000. I will also change the buoyancy damp too. Enable apply drag forces in water so it interacts realistically with physics. I will change the drag coefficients. You can test these values later and set it to what fits best for you. Now we will do the functions. Add one called add mesh attached. Add a static mesh input called mesh and a name input called socket name. Then copy the code shown. Make sure to return the mesh component. This function will spawn a mesh and attach it to a named socket of the parent boat mesh. Next, go to the construction script and add a sequence. Make a variable of the propeller structure type and change it to an array. We are using an array since a boat can have more than one propeller, so this will let us choose different meshes for each one and decide their spinning direction too. For this to work, you will have to add sockets in the boat where the propellers go and name it with a certain convention which I will show later. Copy the code shown to spawn the propeller meshes. This is the naming convention. It must be propeller socket with the correct capitals followed by numbers for each propeller starting from 0. For example, if you have two propellers, add sockets called propeller socket 0 and propeller socket 1, then set the propeller struct to have two elements with the mesh for each and the speed. Duplicate the variable for propeller objects and make sure you change the variable type, which I forgot to do. Add the mesh return value and the speed to the object's variable. Now we can actually access the spawned propeller via the propeller object's variable. We will now add the wheel customization setting. Make a new variable called as wheel. We don't need to use an array for this one, but if you want to add features such as a boat with multiple wheels with more than one character in it, then you can adjust the code. My default mesh was a rowboat, so I will set as wheel to false by default. Copy the code shown. The name of the socket where the wheel goes in the boat must be called what you use here with case sensitivity. Now add the next function called add fluid simulation. Make a variable of type BP fluid sim and set it to instance editable and expose on spawn so we can set its value in the editor. Make sure it's a single type and not array. You can click the drop down and select the value. I showed how to set fluid simulation up in the swimming tutorial, so you can watch just that part if necessary. An alternative way to set it is by getting the actor of class, which would work in this case since you should realistically only have one fluid simulation in the level. Copy the following code for the function. Make sure you select the material override to Fluid Sim Force Boat component, which is included in the plugin by default. I will now comment the function. Now open the character blueprint and copy the default begin play and camera input code. Paste it into the boat blueprint. Find the input actions and make a new one called IA_interact. Add it to the default input mapping context and give it a key. I am using the F key for mine. Go back to the character blueprint. Select class settings and add the interaction BPI and the water interaction 1 if you don't have it. Open the Get Boat Variables interface function and promote each output to a variable. I will categorize the variables. Now go to the event begin play. Create the boat interaction UI, promote the return value, then add it to the viewport. Then add event fade interaction text and copy the code. You can change the fade duration by changing this timeline's length. You can also add a new point to the timeline by holding Shift and clicking. I will collapse the swimming code to a new graph to make the graph more organized. Now add event set interactable. Promote the input to a variable called target interactable. Then add the interact input event. On started, check if target interactable is valid, and if true, then call on interacted with the interacted object being self. This will interact only if there is a target. Now add a custom event called resetBoatIK which sets all the IK variables to their default values. Then add event enter boat. Copy the following code. We set the movement mode back to walking here since the player might have been swimming, which uses the flying mode. Add a switch on using the boat entered type so we can run different code based on it. Make sure the socket name is named exactly as the one you added in the boat, and you set location rule to snap to target. For now, all but the player hidden option will attach the player to the boat socket. If player hidden, just set actor hidden in game to true. Next, add the exit boat event. Copy the following code to reset the variables and states. I will now comment these events. Now add event play boat montage. Copy the code. Go to the boat pawn actor and make a custom event called move boat. We will fill this in later. Call it on notify begin using the boat pawn reference. Now go to your character's animation blueprint. Get the boat variables from the character and copy the code. This setup smoothly sets the IK alpha values so it doesn't just snap immediately. Now go to the anim graph. Copy the default locomotion graph for a boat 1. Save it into a new cache pose called boat locomotion. Open the graph. We don't need the walk-run state machine since the player will only be idle in the boat. We will use a blend by boat enter type enum to dynamically select different animations based on the value. Right-click to add new pins for all the types. For now I will just add the default, sitting and standing poses. Make sure you set the driving idle 1 to looping. In the main anim graph, save the main states graph to a new cache pose. Copy the following code. This chooses between the two poses based on if the player is in boat or not. If you want to disable foot IK if you have precise animations for each, you can add a not condition here to disable it. Make some space at the start. Add a 2-bone IK node and copy the following setup. The joint target location is where the arm should bend, and for the third-person template character these values work fine, but if you have a custom character you may need to change it. Duplicate it for the right hand. Then add a layered blend per bone and add the closed fists animation pose we got. Entering the left hand bone name here will make the animation only play on that hand. Duplicate it and rename it to hand_R. If you have a rig with different bone names then use the correct one. Add the same IK alpha values to the layered blend per bone too. Make sure you change the bones for the second 2-bone IK, I forgot to do this. I will also adjust the joint target location slightly. Now go back to the character blueprint. Add the setBoat IK initial event. Cast to the animation blueprint using the meshes anim instance and set the corresponding IK position variables. You can use a new BPI function here to set it instead if you don't want to hard code it. This event will set the initial location once when the IK begins, so it doesn't initially transition from the world origin to the target position. Next add event setBoat IK. This one should just set each corresponding variable in the character blueprint. We will now start with the boat pawn actor functionality. Select the enter range box and add an event begin overlap. Copy the following code. This will call the BPI events only if they exist in the overlapped actor, which is checked if it is in character first by casting to it. If not, it will just go to the cast failed path. Add an end overlap event to and copy the code. Now select class settings and add the interaction BPI. Compile, then add the onInteracted event. This will be the code that runs once the player presses F to enter the boat. Promote the input to a variable, then call enter boat. Promote the entered type to a variable. You can easily change the default value of this for the child blueprints for different boats. Copy the shown code. The wheel meshes we import should have two sockets called left IK and right IK for this to work. This variable is an offset to adjust the IK position so it holds different wheel thicknesses correctly. I will set the default value of it to -5. We are using a timer here to update the position since the wheel will rotate, and using a timer is better than tick performance-wise. Make a new custom event called non-wheel IK and leave it empty. This will be overridden by child blueprints if they have a different type of IK which isn't the standard wheel type. Call it if has wheel is false. Call interacted secondary in the sequences then 1. This will allow us to give different types of boats extra functionality when entered. I will now comment the event. Now make a custom event called boat timer and copy the code shown. Make one to clear the timer. This uses the clear timer if valid macro from the global macro library. This starts and stops a timer that will continuously run if called. Now add the interact input event and copy the code. The default value of can input should be true. Boat exited secondary will be used in child blueprints so any extra functionality that different boats have can be reset. This temporary disabling collision for the enter range will prevent the player from spamming enter and exit. You can remove this if you want that. I will now comment the events. We will now fill in the move boat event. Copy the shown code. Make sure the default value of steering is false. Move forward amount is important to set correctly for each boat. I will give it a default value of 2000. Clamp max will move the boat at its max value regardless of the input. Since move boat will be used when an animation is used, it should take in the full move value instead of the input value, since the player might have moved then let go of the input while the animation hasn't finished yet. Copy the code for the steer boat event. Steer boat rotates the boat by adding torque. Now make a custom event called limit velocity. This will restrict the velocity, since adding force will continue adding it and the boat will eventually reach very high speeds, much higher than the move forward amount we declared. To limit it, we can clamp the vector size and set it as the current physics linear velocity of the boat. Next, make a custom event called set move held smooth. Make a vector 2D variable called move held smooth. Use the following vector interp setup to smoothly set the input amount so we can make systems blend instead of snap. A higher interp speed will be faster interpolation. Then make another custom event called set wheel rotation with the following inputs. We have a rotation axis input since the wheels might behave differently and need to rotate in different axes, such as a regular steering wheel and a jet skis. Copy the shown nodes. The next events will be for effects. You can skip over this if you don't want it or want to make your own. First will be spawn bubble particle. Copy the following inputs. Now copy the code. I have this bubbles particle I showed how to create in the swimming tutorial. I will put a timestamped link to that section in the description. Min and max speed is used to control how fast the bubbles move, and we have 2 so it can be randomized. Now if you click the parent actor in the component list, on the right side you will see all variables. I made separate folders called setup so I know which ones can be modified, the other ones shouldn't be changed. Some of them can be set to private by definition, but then they can't be accessed in child blueprints, so we can't do that to hide them. You can add propellers easily with the array, and one boat can have multiple with different meshes and speed. This will be explained in more detail during the motor boat video. Wheels can also be added easily, again this will be covered in depth in the motor boat video. Here you can change how the player stays in the boat. This is a row boat where the player sits, so it is set to that one. In physics I have the move forward amount and torque amount. I will now test. The interaction prompt is correctly fading. The sitting, however, is bugged. To fix it, go to Event, enter boat in the character blueprint. We need to exit swimming if we enter the boat, so use a branch condition to do that. You don't need this if you didn't add the swimming mechanic. It is working properly now. You can also exit the boat. I actually used the E key earlier, which was the same as the ascend button, so I couldn't ascend while under a boat. This is why I changed it to the F key instead. I will now do the foam setup example. This part is based off this great video by Peanut Games, so make sure to check it out if you want a more in-depth explanation. I will put a link to his video in the description. First, make a new folder for modified water materials. Click on the water body ocean and search for water material. Browse to it, then find the parent material, as this one is an instance. Copy and paste it into the new folder. Open it and find the sample fluid simulation material function. Open it, browse to it, then make a copy of this as well. Open the copy and find the foam static switch and enable it. Then go to this part and add the following code. This will be used soon for hull masking so water does not go inside the boat body. Replace the function in the material with the new modified one. Now right-click on the material to make a material instance so we can easily edit the parameters. Make sure to set it as the new water material. Change the value of the fluid displacement multiplier to something like 0.25. The reason for this is explained clearly by Peanut Games. Make sure your fluid sim has the same settings as shown here. Again, I showed how to set this up in the swimming tutorial. To test the foam, I will call the Add Fluid Simulation function on Begin Play. Set the target component to the foam scene. The radius and strength requires a lot of trial and error. Also, I found that the results vary when you play in a standalone game as opposed to in editor. I think this may be since the water plugin is still experimental, so it could be a bug. Make sure to add it right at the start. It is working and looks nice now. You will see that the boat is floating a bit too high. One way to fix this is you can increase the Z value of the pontoons to move it lower. It is lower in the water now. I will now modify the force boat event slightly so the boat moves much slower if on land. Add a pin to the multiply, then get is in water body of the buoyancy. Convert it to a float. Add a map range clamped. Copy the values. This multiplies the final move value by 0.2 if on land. You can promote it to a variable if you want to customize it for different boats easier. The final part of the video is hull masking, since currently water can go through the boat. This is also based off a video by Peanut Games, so make sure to check it out if you want a better and more detailed explanation of how it is done. Link will be in the description. You can see when I move the boat down, the water is going inside it, and we don't want that. First, go to the water material. Find and duplicate the water opacity mask from depth function inside it, then open it. Make the following modifications inside it. Update the material to use the new function. We now need to modify the boat mesh externally. I will export mine since it was an imported Quixel mesh. I will use Blender to modify it. Import the FBX. I will delete the collision and only leave the first LOD. We need to close off the top of the boat. Since Quixel is scanned assets, the topology will not be that good for this. If you have your own boat mesh made by hand, it will be a lot easier to do this. Again, Peanut Game's video explains it a lot better than I am. I am using the decimate modifier just to make the mesh easier to work with. You need to delete any obstructions in the mesh, such as the sitting area in the middle. We only need the main body shape, then cap it off at the top. I didn't do it properly here, so we'll skip it and show a different modification soon. Export the mesh as a FBX. Import it in Unreal Engine. In the boat pawn actor, add a new static mesh for the hull collision. Set it to the mesh we just imported. We need to hide its visibility but using a material. Make a new material for hull opacity and set it as masked and unlit. Simply set the opacity mask value to 0. Set the material of the collision mesh to it. The invisible faces is a backface culling issue and doesn't really matter since the mesh is not seen in game anyway. Select the hull collision and set the collision preset to no collision. It should work now, but it isn't. This is since I didn't properly set up the collision mesh. Again, due to it being a Quixel scanned asset, it wasn't as straightforward. I will redo it in Blender with a different approach. You want a single exterior with no thickness and then just close the top off. I am just selecting the outer faces by hiding the interior parts using the camera view. Delete any obstructions such as this handle outside. In Blender, pressing F will make a face using the selected edges. I am now re-importing the new mesh. Now the water is not going through the mesh. It will only go through if the boat is fully submerged, which is realistic. You can see when the player enters the boat, it moves down slightly, which takes weight into account. If you don't want this, you can increase the mass of the boat. Unreal will automatically set the mass if you uncheck the tick box. The buoyancy coefficient will need to be adjusted based on the mass so it actually floats. Now the boat doesn't sink as much when we sit in it. Play around with the values until it looks good for you. One final bug fix is an issue with the getBoat variables in the character blueprint. I made two variables for the entered state. Replace it with the second one and delete the original. That is all for this video. The next few videos will cover how to actually implement the different types of boats, which include rowboats, motorboats, sailboats, and jet skis, so this boat won't actually be playable but just the master blueprint for them. Using this boat pawn as a template, you should also be able to make any other type of boat, but only ones that ride above the water. I will do a separate video for submarines. If you enjoyed, like and subscribe for more content. You can purchase this final result from Gumroad using the link in the description if you want. Each boat type will be sold separately, but if you purchased any one, you will be given a 75% off discount code to be used for the other boats. Thanks for watching.